When we go to solve these application problems with right triangles, the 100% most important thing is that we are able to draw the triangles accurately and label them accurately. We have to understand what it's saying. So we have to read it very carefully. Mr. Szabo needs to climb a ladder to get on top of his roof and fix the siding. His ladder recommends it is placed at a 75-degree angle of elevation. That's the elevation with the ground. So that's telling me that if this is my house, we'll just say that's my house here, this is the ground, the ladder is reaching up here. It doesn't matter how high it's going. If that's my ladder, it is a 75-degree angle of elevation that is with the ground. It's extremely important that that's our 75-degree angle. Then we have to label the rest of this accurately. Now, my house and the ground, I'm still hoping, I guess I haven't really analyzed this, makes a 90-degree angle. The roof is 18 feet tall, so I know this is 18 feet. How far away from the house should he place the ladder to ensure that 75-degree angle? Well, if this is where I'm placing the ladder, and that's my house, I want to know what this length is. That's what I'll call x. I now have my right triangle. I know what side I'm looking for, I know one other side, and I have an angle. It's a trig function. In this case, if this is my reference angle, I know 18 feet is the house, that's opposite my reference angle. X is adjacent because it's my other leg. Opposite and adjacent is the tangent function. My angle is 75 degrees. Opposite is 18 feet. Adjacent is x. There's the function I need to solve. Just like before, in our previous videos, I'm solving for the side of a triangle. X is in my denominator. I would multiply both sides by x, then divide by the tangent. I'm going to get x equals 18 divided by the tangent of 75 degrees. That's what I place in my calculator. I press mode to make sure, yep, it's in degree mode. I can now type in 18 divided by the tangent of 75, and I hit enter. I'm rounding this to the nearest tenth. That's at approximately 4.8 feet. So I would want to place my ladder approximately 4.8 feet away from the house in order to ensure a 75-degree angle. Now let me ask you this question. If I placed it closer, say 4 feet, would that make it a bigger angle or a smaller angle? And that's right. If it was less than 4.8, let's say I placed it here, you can see that makes the angle bigger. This hypotenuse goes a little more vertical, the angle is bigger. And then if I placed it more than 5 feet away, or more than 4.8 feet away, say 5 feet away back here, now that angle gets smaller. It's important to understand that concept. In our next example, we have a pilot of a rescue helicopter flying over the ocean at an elevation of 1,250 feet. The pilot sees a life raft at an angle of depression of 31 degrees. I can't draw a helicopter, so I'm just going to kind of draw this cross up here, and we'll just draw what looks like a funny looking helicopter. And we've got our little rotor back there. There's my helicopter. And I know he is flying up here at an elevation of 1,250 feet above the ocean. The pilot is sitting in here. Okay? It's a see-through helicopter. And he's looking down at an angle of depression of 31 degrees. That's where he's looking, down to here. And he sees the raft in the water over here. Angle of depression is always with the horizontal, so this is not your angle of depression because that's with the vertical. Okay? The angle of depression of 31 degrees would be this angle here. Or we could call it this angle here. Again, This is a horizontal, the ocean is horizontal, parallel lines cut by a transversal, alternate interior angles are congruent. What is the horizontal distance from the helicopter to the life raft? Well, horizontal distance would be measuring from here to here. That's what we don't know. I can use this as my angle. I have the opposite and I need the adjacent. That's the tangent function again. The tangent of my angle is equal to the opposite divided by the adjacent. Once again, I will divide. My x is going to be 1,250 divided by the tangent of my 31-degree angle. And that becomes, divided by the tangent of 31, 2,080.3 feet. So x is approximately 2,080.3 feet away. Now if I had said they see the swimmer at an angle of depression of, let's say, 18 degrees, the swimmer would actually be out here. Let's say that's the swimmer, and they saw them at an angle of depression of 18 degrees. This would be my 18 degree. We could figure out the horizontal distance from the helicopter to the swimmer to determine how far the swimmer is from the life raft.